Hello, dear students. Once again, welcome to this YouTube channel. So, today we have to discuss circular motion. The term circular motion means any object which is revolving around a fixed point, or the path traversed by that particle is like a circle. Or simply you can say the particle is moving along the circumference of a circle. Okay. So ಒಂದು ವಸ್ತು ತಿರುಗ್ತಾ ಇದೆ ಅಂದರೆ ಸುತ್ತಾಗ್ತಾ ಇದೆ ಅನ್ನೋದು ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್. ಓಕೆ. ಸಿ ವೆನ್ ದ ಆಬ್ಜೆಕ್ಟ್ which is revolving, okay, with radius r. Okay, we have already discussed in previous, that is motion in a plane topics. A particle is in circular motion of radius r with velocity v, then it is accelerating towards the center, and the acceleration of the particle is v square by r. Acceleration of the particle is v square divided by r, and directed towards the center. Okay, and according to the second law, the force providing this acceleration is mass into acceleration, that is mv square upon r. Okay, so where m is mass of the body, and v is the uniform speed, uniform circular motion, and r is the radius of the circular path. Okay, and this force is directed towards the center and is called the centripetal force. Okay, so for a stone rotated in a circle, the tension in the string, okay, the centripetal force is provided by the tension in the string. The centripetal force for motion of a planet around the sun is the gravitational force on the planet due to the sun. Okay, similarly, for a car taking a circular turn on a horizontal road, the centripetal force is the force of friction. The centripetal force is the force of friction. Okay, see, now the motion of a car on a level road. So three forces act on the car as shown in the figure, previous figure. See here, three forces that will act on the car. One is mg acting downward, another one is n which is normal to the surface, and one more is the frictional force. Okay, now see, the weight of the body or weight of the car is mg, and normal reaction is n, and third one is the frictional force F. Is it clear? Okay. Now, as there is no acceleration in the vertical direction, then clearly n minus mg equal to 0 or n equal to mg. That is the normal reaction. The normal reaction is equal to the weight of the body, or weight of the car. Okay, so that is n equal to mg. The centripetal force required for the circular motion, the centripetal force required for circular motion is along the surface of the rod and is provided by the component of the contact force between rod and the car tires along the surface. This by definition is the frictional force. Note that it is the static friction that provides the centripetal acceleration. Static friction opposes the impeding motion of the car moving away from the circle. Moving away from the circle. Okay. So we have already discussed about the friction. That is, the static friction is less than or equal to mu s into n, and also just we have discussed F equal to m v square by r. So now by equating this m v square by r and mu s n, F is less than mu s into n, and that F equal to m v square by r. Okay. So therefore we can write m v square by r is less than or equal to mu s into n, or v square is less than or equal to mu s r n upon m, and here n equal to mz. Capital N is the normal reaction, and that capital N equal to mz, that capital N equal to mz. So therefore we can write v square as mu s r into z, which is independent of the mass of the car. This shows that for a given value of mu s and r, there is a maximum speed of circular motion of the car possible, namely square root of mu s r into z, square root of mu s. Okay, square root of mu s. Okay, you can use this square root of mu s r into z. So this is the expression for the maximum speed of the vehicle on a level road, on the level road. Okay, the road is not inclined, remember. Okay, so now by knowing about this, the motion of a car on a level road, okay, so the maximum speed of the car is square root of mu s r into z. Okay. So in next class we have to discuss the motion of the car on a banked road. Why the roads are banked? The roads are banked to improve the centripetal force. Okay, means the vehicle can easily turn in a curved path. Okay, so that we can discuss in the next video. Okay, thank you.